Hi everyone. So I've heard a few questions from students about this Unit 3 project, and it's a pretty significant project, and sometimes it's hard to know what in the world to do or how to get started. So I'm just going to walk through some general tips for success on the project, and then some things to think about for each of the four tasks as you get going. So, one thing to keep in mind is to take your time on this. This is not just a one and done project, as in you're not going to sit down and just get it done in 10 minutes. It's worth 50 points, which is a solid chunk of points, and it's worth that much for a reason. It's because there's a lot of work involved and a lot of mathematical skills represented in it. But also, it's not a one and done as far as your attempts. If you try it and have some issues with it or you didn't quite understand it, I'm more than likely going to be open to giving you another attempt on it if you would like. Also, you're going to want to work through each part methodically and check your work because a little mistake at the beginning is going to impact the larger part of any one of the tasks. And that's true of any other like math class you're going to take after Algebra 1, such as Algebra 2, Pre-Calc, etc. Those little things end up changing the problem later on or the answer you're going to get. So check your work carefully, take good notes, and show your work well. It will help you when you come back to it the next day, if it takes you a few days to work on this, and it will help me when I'm grading your work. You're going to want to have pretty detailed work to show me how you got your answer for the final product or the final thing that you're going to turn in. Pay attention to units, that is feet versus miles. You're going to use plenty of both. You're going to want to make sure you show units in your work and that you're converting correctly, and we're going to talk a little bit about that in a minute. And then ask for help along the way. And as you ask me for help on it, be detailed. Show me where you're at in the problem. As many details as you can provide me, the more detailed of response and quicker of a response I'm going to be able to answer for you, as opposed to asking you follow-up questions and then emailing back and forth. And finally, you want to submit the final project in a viewable format, such as a PDF. You could use something like Google Slides or Google Doc, as long as you share a shareable link that's viewable outside of your school, so you can change the permission setting. But probably what's even easier is just download it as a PDF under the file setting, and then you're good to go. Anybody can view a PDF. And you're going to want to check out the rubric on this one, as well as really any of your assignments in class, such as the discussion activities. When you look at the rubric, you'll get a good feel for how I'm going to grade your work in advance. All right, let's talk about the specifics. Task 1. So in New Hampshire, we've got this mountain that's about 4,300 feet high, and is used for a variety of things. At one point during the drive to this mountain, the road rose in elevation from 1,000 feet to 1,900 feet, and that happened in a distance of 4 miles. Use your knowledge of slope and percent grade change to find the percent grade change of this road, or this section of road that's 4 miles. So let's think through some things first of all. I'm going to draw a diagram here to kind of help me visualize what's going on, and I encourage you to do the same. And in fact, I would encourage you to have this in your work for the final project, or the final product that you're going to turn in. And let's talk about what we know so far and apply this to the diagram. Notice that I've got it looks like a right triangle here, and if you're familiar with geometry at all, the hypotenuse is that longest side, and that's going to represent how we're going up. But some other things I know about that, we're starting out over here on the left at 1,000 feet already. That's the elevation that we're starting out with, and at the end of this section of road, we're going to be up at 1,950 feet. Along with that, I know that I'm going for 4 miles. So in terms of like the horizontal length here. And here are some tips as well to go along with this. So I know that I know I can calculate this side over here, right? I started at 1,000 feet. I'm going up to 1,950 feet. That's a pretty easy calculation of this side of the triangle. And I know this side is 4 miles. I also know that 1 mile is 5,280 feet, and you're going to want to convert either the miles to feet or the feet to miles so that we're comparing apples to apples. As far as what I'm trying to find, notice the question says use your knowledge of slope and percent grade change. Those are both in the directions for this activity to find the percent grade change of this road. So I know that slope equals rise over run, or change in y, over change in x. And so again, I've got my x over here, or the run, and then I've got the rise, the change in y over here once I do this subtraction. Again, I've got to look at the units and get them in the same unit. And then when you calculate that slope, to calculate the percent grade change, you're just taking that slope and multiplying it by 100. That's what we do to get to a percentage. Okay, those are some tips to get started with this task 1. On to task 2. The Mount Washington Auto Road begins at a certain place at 1,600 feet of elevation and rises to a parking area just below the summit of Mount Washington, which is 6,288 feet. Notice I don't have the whole problem in front of me or the whole task. I just have some of the most important information here. The roadway is very steep and curvy, and the roadway itself is 7.6 miles long from the bottom to the top. Calculate the percent grade change for this roadway. So we're doing the same thing. We're calculating the percent grade change, but we have a little bit different information here. I've got my triangle, and notice this time I put the right triangle sign in the bottom corner here. The other triangle was also a right triangle, but I especially wanted that to be clear in this one, and I'll show you why in a minute. And then I know that, again, we're starting at 1,600 feet of elevation. We're going up to 6,288 feet. So again, we're doing percent grade change, rise over run, or change in y over change in x. Well, that change in y is pretty easy to figure out here, right? And I also know that the road itself is 7.6 miles long. This is a little different than task 1, because as far as the road itself, that's the hypotenuse. That's actually what's going up, right? And that's what's 7.6 miles long here. So that's a key distinction between this one and the last task. What I don't know is the change in x, or how long this triangle is going to be, okay? And even though it's nice to know how long the road is, if I'm going to calculate the percent grade of change, I don't really need that information. I do need change in y and change in x. So some tips or some hints here. Again, I know how long a mile is. I know how to calculate slope and the percent change. This time we're going to also be looking at the Pythagorean theorem. Why are we doing that? Well, this is a right triangle, and in any right triangle, a squared plus b squared equals c squared. In other words, the length of one of the legs squared plus the length of the other leg squared is equal to the hypotenuse squared. And we can represent these three values with these sides of the triangle, a, b, c. B and A are actually interchangeable. The C is not, though. That one, it has to be the hypotenuse, which is opposite the right angle, or the longest side of the triangle. So you're going to need to remember, you're going to need to work in terms of the same units here, feet or miles. You get to choose. Either way, you're going to be doing some converting, and you're going to be doing some squaring. A squared, that just means A times A, right? So you're going to end up working with some pretty large numbers, even in the millions or hundreds of millions. So know that that's normal for this problem. It's a necessary part of it. And you're gonna, ultimately we need to get this B value so I can run this rise over run percent grade change and then multiply it by 100. So hopefully that helps with task 2. Task 3 is not too different. There's one little nuance to take a look at. So we've got this Camp Muir trail. The trail is a 9-mile round trip trek. Ding, 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 ding. That piece of information is really important, and I'll show you why. And it's got an elevation gain of 4,788 feet. Talks about how long it takes to hike this, which is quite a hike if you've ever done hiking. And your task, again, is the same thing. Calculate the percent grade change for this trail hike. So let's look at our diagram one more time. Same type of deal. Again, these are not drawn to scale, but it just helps us visualize what's going on. This time, what's nice is the change in y has already been calculated for us. It says an elevation gain of 4,788 feet. So, yay, one less step. And I know that the trail, again, the trail is what's going up, right? That's it's a 9-mile round trip trek. And I don't have this value here just like before. The thing to think about though is I know that the round trip for this hike, remember round trip is like there and back again, or up and then down the trail in this case, is 9 miles. So is this going to be a round trip length or is this going to be something else? That's for you to think about. Some other tips. Again, watch your units. We know that a squared plus b squared equals c squared, just like before. You're going to need to use that Pythagorean theorem to solve for b, or to solve for this unknown value here before I can do rise over run, or change in y divided by change in x. And then once you have that slope, you're going to multiply it by 100. Okay, last reminders, overall stuff. I didn't talk about task 4, that's the part where you're going to reflect on your project, but take the time to write this thoroughly, make it very professional looking, proofread your work. Don't just throw it together last minute. You shouldn't have like lowercase i's and not capitalizing the beginning of sentences. Make it look real nice and professional. Take the time to present yourself well. Again, take your time with this one. It's not a one and done. It's going to take you probably multiple sittings to work through these problems. That's totally fine. Again, it's kind of worth it because it's a 50-point project. And if you're really, let's say you're just really not happy with one attempt, I might allow you another attempt on it. Take good notes and show your work well in the final product. I need to see your work written out. Even if you had the correct answers and did not have much work, you would not be scoring super highly on this one. Submit the final project in a viewable format. We talked about that, and check out that rubric so you know what to do. Best wishes on this one.